Okay, so in this section we are actually going to go back to the beginning here of our notes and take a look at carbon chemistry. So what we have to understand is that carbon, it has its own branch of chemistry, organic chemistry. So any of these compounds that we call organic that we just talked about, the carbohydrates, the proteins, the lipids, the nucleic acids, all fall under this branch of chemistry. So because these molecules tend to deal with life, we can call it the chemistry of life because the molecules that are usually involved here, that we're going to be talking about, are involved with life. Now, carbon is present, like we said, in all organic compounds as long as it also has hydrogen. Remember, carbon by itself doesn't make something organic, and hydrogen by itself doesn't make something organic. And organic means different than natural. You can't confuse the two. And part of the reason why carbon kind of has its own branch is because it has some very unique properties that we don't find with other atoms on our entire periodic table. First of all, carbon is able to form up to 4 different bonds, and that's because it has 4 valence electrons. It combines with other elements using these bonds, but it also can combine with other carbon atoms, which allows it to form both rings and chains. And these chains can be long. They can be hundreds of carbon atoms long, and no other element is able to do this. Oxygen has the capability a little bit, sulfur as well, but none of the other elements on the periodic table can form the lengths of chains strung together like carbon can. So because of this, carbon is able to form these what we call macromolecules, those 4 different classes that we talked about, the carbohydrates, the lipids, the proteins, and the nucleic acids, and these are giant molecules. And these typically are polymers. So examples of these would be things like starch and DNA. So let's take a look at this whole idea of a polymer. Polymers form through the process of polymerization, and this is actually the process where we take small pieces and we join them together to make a large compound. When the small compounds get joined together are what we refer to as a monomer. Examples of things like monomers are things like glucose and a nucleotide. So we take these and we chain them together, we literally stick them together to form the polymers. So we can think of monomers as the links that make up the chain, and the chain itself is your polymer. And if you look at the words themselves, they tell you something. Mono means one. Well, this is actually a depiction, and I know there's a picture on your note packet here. So these little pieces here are the monomers, and they come together, and when they fit together through the process of polymerization, they actually form the polymer. So like I was saying before, if we look at the words themselves, the prefix mono means one, and so therefore monomer means 1 unit. The prefix poly means many, and so the word polymer means that we have a chain of many. So let's take a look at actually this process of how we actually form polymers, and then we can also do the opposite process. We can break them up. So the process of making a polymer happens through, the process of making the chain is called, like I said, polymerization. And polymerization often happens by the process of dehydration synthesis. If you think of the word dehydration, when you are dehydrated, you don't have enough water in your system. So it's the same thing here. It's just what we're doing is we're putting some things together, and in the process, we're kicking off a water molecule. We are removing water. All right, so dehydration synthesis is the removal of water molecule in order to join 2 molecules together. All right, so let's take a look at an example here. Get my board up and running. Okay, so an easy example of this would be to take glucose. And remember, glucose is that hexagon shape. Okay, it's a monosaccharide, so we know that's a monomer. And we can take another glucose, and what we want to do is we want to chain them together. So we want to hook them up. And when we do that, we actually create something called maltose. So now we have a disaccharide, okay, but we also have water. So in the process of forming this bond, we actually kick off a water molecule, and that's dehydration synthesis. We'll actually take a look at that a little bit more in depth here in a second. All right, so if you flip over into your handout packet, you've got the dehydration synthesis worksheet. And what we have here is, excuse me, the top diagram called synthesis of a fat. So what we're going to be doing is, if you look at this one right here, this is your glycerol molecule, and then we have 3 fatty acid molecules here. Okay, so they're actually separate. We've got one here, okay, one here. Notice that they are separate things, and one here. Okay, so we've got 3 fatty acid molecules. So what we're going to be doing is we're going to be hooking those fatty acids into our glycerol molecule. And I'm going to show you actually how we can actually take off the water. So if we look here, water is H2O, so I have an O and an H, and then an H here. So we're going to circle that because we're taking off our water. And then we're going to circle this because we're going to take off another water here. And the last one we're going to do is down here. So we're going to pull these 3 waters off, and notice that it leaves these oxygens here now without a partner. And oxygen needs a partner, but so does this carbon, and this carbon. So what we'll do is we'll take that out, and we'll actually combine the carbon and the oxygen to hook everything together. So, what does it look like at the end? Well, we will start with the chain. We've got the 3 carbons, the hydrogens off to the sides here. And remember, they have their empty bonds there. Now, on this first one, we're going to take the O, now that's from the fatty acid, and then we're just going to hook everything else on. And then the same thing down here. And then the same thing down here. So this is our fat molecule. And then we have 3 waters, because remember, that's what we have left over. That's what we circled, and those get pulled off. Now, on the bottom, we have this formation of a peptide bond. Okay, so on this one, let's circle where we're actually going to have the water molecule coming off. And what we're going to be looking at is this OH and this H right here. Notice that it leaves this carbon and this nitrogen in need of a partner. So what's going to happen is they are actually going to join together. These are both amino acids. Now these happen to be the same amino acids, and that doesn't always have to be the case. So what is our net result? Get to the next screen here. Here we go. All right, so what I would end up with is my first amino acid here. Now, this carbon then joins to the nitrogen of the other amino acid. So this is a new bond. That's our peptide bond. And then I add on the rest of my amino acid. So this is my dipeptide. plus I have a water. Okay, so those are dehydration synthesis. So remember, we can do this more than once. Like with the fat, we did it 3 times. So we could continue with, for instance, with the peptide bond and actually continue it many, many more times to make an even bigger protein. So can this process therefore be reversed? And the answer, of course, is yes. Yes, it can. So the opposite of polymerization is depolymerization. And depolymerization is where we break apart a polymer into its monomer components. So we take the pieces and we pull them apart. This process is typically through hydrolysis. So if you look at the name hydrolysis, hydro refers to water, lysis means to cut. So what we're doing is we're literally chopping up the molecule using water. So hydrolysis is using a water molecule to split a larger molecule into 2 smaller ones. And our example here is going to be kind of the reverse of the example we did above. So we're going to start with maltose. This is our maltose. And we're going to add water. And this water is going to go in and it's going to attack that bond. And what we're going to get is glucose plus glucose. Okay. So again, back over in your handout packet, let's take a look here. We are going to break apart. We're actually just going to do the breakdown of the lipid, the one on the bottom. So we're breaking down this lipid, and we're basically doing the reverse of what we did before. So before, what we did was we took the glycerol molecule and the 3 fatty acids, and we went ahead and shoved them together. And we know that in here is the bond that we created. So remember, this water molecule is going to go in and it's going to attack that bond. Okay? So let's take a look at what happens when we're done with this. All right, so we get a glycerol molecule. Now these OHs come from water that I just drew in. So this is my glycerol. And I get 3 fatty acids. So here I have, so I've got the oxygen. Now it gets that hydrogen. Okay, remember this is from water and this is from water. So 2 H's and an L. And then I have the same thing here. And then I have the same thing here. Okay, so those are my 3 fatty acids. Sorry, I'm not doing things well here. All right, now we can do the one in the top. So with the one in the top is the breaking down of the disaccharide that we kind of use as our example. Now the reason why I didn't do this one first is because it's not just the opposite of what we had already done. So what we do is we take this water and we're actually going to go in and we're going to attack this bond right here. So my water is going to split again into HOH. This H here is going to attach to the oxygen, and then the OH is going to attach to the carbon. So this is what we're going to end up with. Sorry, my board is not behaving appropriately. There we go. All right, so I'm going to kind of simplify this. I'm not going to draw everything. Okay, so that's my ring. And here I'm going to have this. All right, sorry about that. I was getting called by my children. All right, so we've got the one glucose molecule here, and it's got this new OH off of the end. Okay, so we've got glucose. Now, we'll also have another one over here. Now, this carbon here was attached to the oxygen here. So it needs a partner, okay? And it now has the OH off of it. So we've got another glucose. And we've used up the water. All right, and that kind of concludes our section here on the carbon chemistry.